Okay, so let's go ahead and get started. One thing that I do want to say before we get started on the main lecture is there wasn't a lot of time to talk about the rest of the rules for this college is useless essay, so let's just talk about that a bit briefly. The one thing that I didn't say was the style. I don't really care how you write your essay as long as it looks like an essay. You don't have to cite anything for this particular essay, but eventually you will, and just be consistent. As long as I can read what you're trying to say, I am totally happy. There's also a programming language that you can learn to write an essay in, which is really interesting. If you would like to learn it, click on the tutorial link. Definitely not required. Eventually you'll have to learn it if you have like a math-heavy major. One thing that I do really care about that one of my English instructors has instilled into me, and I will never forget, is this is my one rule is regarding style. I'm going to mark you down if you use contractions or if you have very informal writing. This is an essay, right? It's a formal essay. That's the one thing. Okay, so just Control F, search for an apostrophe, and make sure that any contractions you are using are in other people's quotes, right? None of your own words. That's all. Any questions about this essay? I think that's all I really wanted to say. You know, I think I can't promise it, but I will just give you my eternal praise. How about that? All right, are we ready to learn about variables? Variables and branching. So this is a programming day, so please go to scratch.mit.edu, click Start Creating, and let's do cool stuff together. The very first thing I want to do is talk to you about variables because those are going to save us from having to like retype a bunch of stuff or not be able to do some things. We need variables to do certain things. So the idea of a variable is it's just a box. It's a place with a name, like X, where you can put stuff. So like maybe I can put 42 in the variable X. That's all. And that's very useful because then I can just say X rather than saying 42 all the time. And I think you can imagine if this was a giant number, it would be much more convenient to just keep saying X, right? So that's the first goal. Let's talk about variables. They are things where we can store information and we can use that information later. So a variable is just a box. That's all it is. And so you can have a box called X, put into it whatever you want, 1,234. And later on in your program, you could ask stuff about X. You can get it back out, print it back out. Or you can do arithmetic on X, which is nice. Like you can output X plus 1 now. Isn't that nice? And then every time you get input from the user, you ask the user to type something in Scratch, it'll go to a special variable called, not input, but I think answer. So if you want stuff from the user, you're going to have to use variables anyway, so you might as well get used to them. And then you can do stuff like, what is input times 2? Do very fancy things. And also reset boxes, like make this 1, 2, 3, 5, if you wanted to. Okay, that's what a variable is, and I would like to show you that example, show you an example of variables with this program. Let's ask the user for their name, and then we'll greet them. We'll have the Scratch Cat greet them, say hello, and then the name that the user typed. That sounds like a good idea to me. So the first thing that I want to say is when you are reading text data, like words, it's going to be stored into an answer variable eventually. Like we asked the user for their name, and it's going to be stored into the answer variable, whatever they typed, so I'll type my name. When you have text data, that's different from number data, and text data is called a string. It's a weird name, but that's just what they call it. A string is just a bunch of characters. There's a difference between the string 1, 2, 3, the characters 1, 2, 3 without any meaning, any extra meaning, and the number 1, 2, 3. Okay, it's weird to think about that, but it is true. Okay, I guess you can think of string as like a string of beads on like a friendship bracelet or something with letters. That's maybe why they call it that. So with numbers, if you have 1, 2, 3, the number, if I can spell number, you can do number stuff. You can add numbers, you can multiply numbers, divide them, all that cool stuff. But for strings, for characters, you can't really do, you can't like multiply words together. That makes sense. You can print out some words. You can combine some words over here and some words over there. There's a block called join that does that in Scratch. There's other words for that same idea though. But yeah, what I'm trying to say is that variables have types behind them. Like this is a string. You can print it out. You can add it to the end of hello, comma. Whereas this is a number. You can add stuff to it. You can multiply stuff to it. You can't put like hello in front of it, kind of thing. You got to convert it to a string if you want to do that. So Scratch is very nice. It just like if you type a number, it treats it as a number. If you type some words, it treats it as a string. But once we get to Python, remember this day, remember this moment, and it will all come crashing down. Okay, so let's make this program. Hello, your name here. So let's start off the program when the green flag gets clicked. Let's say that it's the Scratch Cat who is going to do the talking and the asking. So the very first thing we got to do is let's ask the user what their name is. And is it sensing? Yeah, here we go. Here is an ask block. Ask, what's your name? And wait. Oh, that's convenient. And then the second you type something, it's going to be filled into this answer variable sitting right here. You see that? I can drag it out. I'll put it somewhere new eventually, but ask what's your name. Lawton. You can either hit enter or click the checkbox. And then it got the name, and it saved it into the answer variable. It filled in that box. I can click it to see the contents of the box. So Lawton's in it right now. Maybe if you ask my cat what its name is, what his name is, they'll say Lonzo, and now answer holds Lonzo, because it's a different value. It filled the box with something new. Okay, so answer is a variable. It is a variable that goes hand in hand with the ask block. That's why it's next to it. Anything that you ask the user for, and they enter, goes in the answer variable. Okay, simple. Hopefully not too horrible. Are there any questions about that? All right, let's keep on trucking then. So, yeah, once I type something, boop, it's here. And it's stored in the answer variable. And I would like to print out hello, comma, space, your name, exclamation point, right? So I can say stuff, right? I can say stuff with the, as that looks, say hello for 2 seconds. No, I say like the name, say answer for 2 seconds. You can put that right in there. Isn't that nice? So what's your name? Lawton. And then Scratch Cat says Lawton for 2 seconds because I told him to say answer. Whatever answer is, it gets replaced with the value of that variable. And he says it. If I want to say hello answer, hello Lawton, then I need to combine strings, right? So here is the join block that combines 2 strings. You got 2 strings, you put them in both sides, and to run the block, it computes those 2 strings right next to each other, the bigger string. Okay? You're getting used to me saying that word by now, hopefully. So if I want to join hello, comma world, or not hello, comma world, hello, comma your name, I'll just say hello, comma, and then I'll put answer right here, and that's what we want, right? Say that for 2 seconds. Type Lawton, hit enter, hello, comma Lawton, but if you look closely, look at that. There is no space after that comma. That's disgusting. We're going to fix that. I don't want to join hello, comma with answer. I want to join hello, comma space with answer, don't I? Does that make sense? I'll make it pretty. Much better. And then we need the exclamation point at the end, right? So there's 2 ways to do it. You got 2 options. You need to use join again. Depends on where you want to put answer, I guess. Do we only have 2 options? No, we do have 2 options. Here's one of them. Take what we had before. So that was the hello, comma, space. And then put an exclamation point at the end. You're joining some joins. So the inner one's calculating hello, comma, space, Lawton. And then the outer one's taking that hello, comma, space, Lawton and putting an exclamation point at the end of it. It doesn't matter what you typed. It's just hello, comma, space, answer with an exclamation point at the end. Does that make sense? The alternative to this, if I can copy this, duplicate. So this will work. Compute, proper thing. You could also do it this way. You could say, put it at the end here. You can say hello, comma, space, answer, and then join that with an exclamation point. So first it's computing Lawton exclamation point, then it's putting hello, comma, space at the front. These do the same thing. Interesting, we have options. There's a million different ways to do the same thing in programming. Any questions about that? Join of a join. Join in the first, join in the second. Doesn't really matter. Because the join operator is associative. That is the fancy mathematical term for what's going on here. So that's what I want to say for 2 seconds. Do it, please. Hello, comma, space, Lawton, exclamation point. Yay. Does that make sense? So that's the full program. You can zoom out so you can see the whole thing. But that's all we need. Not too bad, huh? So ask, and we get the answer. Answer in the variable. It fills in that box with whatever we type. If I type something different, like my cat's name, it'll put that in answer and use it. All right. First program, complete, saved, so you can have it later. Next program, let's get the absolute value of whatever the user gives us. So let's ask the user for a number. We will output the absolute value of that number, okay? And just for fun, to keep us awake, let's make this program start when we click the scratch cat. Why not? So the idea is we're going to ask the user for a number, and the answer is going to go in the answer variable. So maybe they typed -42. And then we want to output the absolute value of that number, which is +42. Yeah. Let's calculate that. Let's do some number stuff this time, rather than some string stuff. Sorry, desk. Start all over. And so let's make this work when the sprite is clicked. When I click the scratch cat, run all this stuff down here. So we'll ask the user for a number, enter a number, and wait. And then we get that number in the answer variable, right? And so we eventually want to print out an answer. So say answer for 2 seconds right now. Oh, it's not going to work when I click the green flag because it's going to work when I click the sprite. There we go. 42. Oh yeah, 42 is what he says for 2 seconds. Click him again. -42. -42 for 2 seconds. Let's calculate the absolute value. That's very easy. It's down here in operators. It's already made for us. The absolute value of whatever. The absolute value of answer. And there's a bunch of different options here. These are a bunch of different mathematical functions that you can use to do cool stuff, but we'll keep it on abs. That's short for absolute value. So it'll take my -42 in answer and make it +42. Oh, sorry. Say that. That's interesting to think about. I never realized that. You can calculate how many seconds you want it to say something. And it could be a different number based on a variable. That's cool. I never thought about that until just now. Enter a number, 42. The absolute value of 42 is still 42. Enter a number, -42. Absolute value of that's just 42. +42. Okay? So that's number stuff. Again, not horrible, I hope. Questions about that one? Let's increase the difficulty now. So, what do I want to do? We've been working with the answer variable. Let's make our own variable now. Let's make an x variable. That thing I've been drawing. Let's make an x variable, and let's have it increase when we press the space bar. So like maybe x starts out as, I don't know, 44 in my little example down here. And then when we press the space bar, it's going to run stuff, and it'll make it 45. Won't that be fun? Maybe if we press it again, we'll make it 46. But let me show you what's going on here. I guess I'll do this exact program, and then we can make it cooler if we want to. Because there is a problem in this program. So, new program. To make your own variable, you go down here to the variables section. That's pretty logical. Every Scratch program starts with a variable called myVariable, which you can right-click and rename to X. Or you can also just click Make a Variable for whatever you want. Call it Y. Okay. So you can make as many variables as you need. I only need X right now, though. So X, I'm going to use that. And then all these blocks down here manipulate the variables that exist in my program. So I only have x right now to work with. So this is like a set x block, change x by block. Okay, show variable x block. This is kind of nice. So I can set x to 44, click it. Now x holds 44. I can also just keep it around in the window of the program with the show variable block. It goes up here. See that? That's pretty nice. And so I can chain that, and then I can change x by 1. If I click that, it'll make x 45. You see it up there still? X is now 45. And then I can show it again. Should already be shown, but whatever. So that's a program that we can start when the space key is pressed, just to get all of our options out here. But something weird is going to happen when I run this. I'm going to press the space button right now. Watch this variable up here. Boop. 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 45. It is supposed to be 44. Like this code is setting it to 44, showing it, changing it by 1, and showing it again. Why am I only seeing 45? Crazy. The issue is that our computers are so fast that all of these 4 blocks are happening before the screen can refresh itself. So technically, x is 44 for a split second. We just can't see it. If you want to see it, you better wait in between. Yeah. That's in control. Yeah. Wait a second. Then do your thing. So I press space now. You can see that's 44 for a second, then it's 45. 44 for a second, then 45. Yeah. Does that make enough sense for us? So if we want to see something happen for a block that doesn't say do something for something amount of seconds, you can just imagine that that block executes immediately. And if you want to see something happen, if you want to see something change, you better wait at that wait block. Okay. Am I good with that? I think a more fun program than this, I'll just save this because this is what was supposed to be part of the slides, but a more fun program than this would be something like, let's initialize x to be like 0 when the green flag gets clicked. So boop. And then you just always have x being shown. And then every time you press space, let's change x by 1 and keep it shown. So now green flag to reset, and now I can press space and it's a little counter. Change x by 1, show it. That's pretty fun. And I can press the green flag to set it back to 0. If I hold in space, apparently that's as fast as it can register the space as being pressed. That's pretty nice. I think these numbers can be as big as you want them to be, so I'd be here all day if I wanted to see it overflow. But that is variables, making our own, changing them. Okay? If you wanted to decrement your variable, you just change it by -1 rather than increment it. Does that make sense? Questions about that? Making our own variables, working with them. And that's like the first part of today. The next part of today is making fancier programs, okay? Because every program that we have written so far is a straight line. You got your little event to start off your computation, whatever it does, and then you chain your blocks like this, right? One after the other after the other. Boop. Boop. To do thing A, thing B, thing C, thing D in order from top to bottom, right? It's going to do A, then B, then C, then D. Wouldn't it be nice if we could do other things? Rainbow. There are 2 things that we would like to be able to do, and that will allow us to compute anything computable. The first is called branching. So that'll be the topic of the rest of today, in addition to loops. So branching looks like this. It's like do thing A, and then depending on some condition, either do thing B or thing C, not both, one or the other. And then maybe you can do a bunch of things and then come back later to do thing D after you've done your alternate options. called branching. Like the program could split off one way or the other. And then the final way, that will give us the full power of programming, is called a loop. That's like you have thing A, you have thing B. You can come back to do thing A again and loop around. That's why it's called that. Okay? So those are the two missing pieces right now, and that's what I'm about to show you. Does that make sense? That's where we're going. So here is my first silly example of a loop. Loops are actually easier in Scratch because the repeat block is very easy to think about. So I'm going to make, this is an example of loops. I'm going to make this program. When the up arrow is pressed, I'm going to ask the user how fast I should spin. Apparently this is the Scratch Cat ready to do like a cartwheel or something. And then we will turn by that degrees amount that the user types, because it's supposed to be a number. We're going to turn by that degrees amount 10 times very quickly. Okay? This is called a repeat block. Isn't this neat? So it's a little block that holds blocks. That's pretty nice. And you can tell it how many times you want to repeat the stuff inside. So this is number of times to repeat the inner code. And then everything that you put inside of that block gets run that many times. So this is going to get run, this turn answer degrees to the right, gets run 10 times. That's so much better than putting 10 of these right after each other, isn't it? That's beautiful. So that will be our first example of a loop. When the up arrow is pressed, sure. So I'll change space to up arrow. When the up arrow is pressed, we're going to ask the user how fast they want us to spin. Because the whole idea is they're going to type a number, and like if you turn right by 15 degrees, you move kind of slowly if you click that. But if you turn right by 30 degrees, you turn a bit faster. That's going to like be speed for us. That's why. So we're going to turn answer degrees. So ask the user for a number. How fast should I spin? And wait. We're going to get that number. And then we're going to turn by that amount. That'll be our degree amount. Higher number means we spin faster. We're going to turn by that amount 10 times. So in control, we're going to repeat the following block 10 times. Turn by answer degrees. So it's like clicking it really fast. Okay? So how fast should I spin? No, sorry. When the up arrow is pressed. So I'm going to press the up arrow. How fast should I spin? Let's spin 5. 5 degrees at a time, and we'll do that 10 times. Hit enter the check mark. And so we moved pretty slowly, but 10 times. By 5 degrees. Up arrow again, if I say 15, we moves a bit faster. Up arrow again, if I say 30, moves super fast. You can do 1, spins barely at all. 2, 55, there he goes. So yeah, a very dizzy Scratch Cat. That is an example of a loop. It is code that runs code multiple times. Any questions about that? It's actually a really hard topic to teach in a non-graphical language. I'm not even here. I'm not even 2 loops in my CSCI 40 class yet. So you guys are ahead. All right, are we ready for branches? To do one thing or another? All right. Let's do it. So, let's see, where do I want it to be? Yeah, this is fine. Plenty of time to get started on your next programming assignment, I think, today. So let's talk about branching. And branching is based on conditions. So essentially your program is asking a question, and if the answer is yes, it does one thing. If the answer is no, it does another thing. That's how it determines which side of the branch to go down. That's how that'll work. So yeah, let me draw that idea. So we want our programs to branch like they're little roots of a tree, or branches of a tree even. And so that means we want them to do one thing or another depending on something. All right, so maybe if the answer is 42, which it's supposed to be, right? If that's a yes, we do one thing, and if it's a no, we do some other thing, right? We do thing A if it's yes, we do thing B if it's no, and then maybe we come back after that's finished and we can do some more straight line code down here, okay? That's what we'd like to do. So our programs, we'd like them to do one thing or another depending on some condition. Here at the top is our condition, okay? This is something to check. This is a condition. I don't know if I want to use arrows because now I've used a ton of arrows. This is a condition. A condition. Something that we can test. Okay? I'll get rid of this line as well. That's the general idea. Let's slowly get towards concrete things. So in computer science, we don't say yes or no because we're cooler than that. We say true and false. Okay? So the type of answer, the type of a yes or no answer, the type of something that gives back true or false, that's called a Boolean, named after George Boole. Remember him from the first day of class? So a Boolean is a value that is either true or false. Okay? I say Boole for short. And so we ask questions of our program that have yes or no answers. And so if it's a yes answer, that means it's true. If it's a no answer, that means it's false. So yes is equivalent to true for our purposes, and no is equivalent to false for computer scientists. We say these words instead, okay? So we'd like to ask questions like this. Is answer equal to 42? Is answer less than 0? Is answer greater than or equal to -7? Stuff like that. Yes or no questions. And the computer can go and check. Scratch can go and check and say yes or no. And depending on that answer, we can do one thing or another. That's beautiful, okay? So we'd like to be able to do something if that question is true, and potentially some other thing if that question is false. The answer is false, okay? That's all. So let's see here. I think that's what I want. And I'll have you try it. Okay, yeah, I see where I'm going with this. Just reminding myself. So, for example, we don't need the abs block to calculate absolute value. I'm going to show you how to program that. Okay? And I'm going to have you try it. So, for example, if answer is -42, we want to compute positive 42 based on -42. And then if answer is positive 42, we want to just keep it what it was. Just keep it normal 42. Yeah? So here's the idea. Here is how you can use a program, write a program that involves branching and checking answers, yes or no answers, to calculate the absolute value. All right? Here's how you can do it. First of all, you got to get the input, get something into your answer variable. That's a block that we know. And then we have a condition check. Because to calculate the absolute value of a number, it's either you multiply it, you either negate it, right? You either multiply it by -1 if it's negative to make it positive, or you don't touch it if it's already positive. Yeah? So those are our two options. So you check if the input, and by that I mean answer variable, check if that is less than 0, because then it's negative, right? If it's negative, we got some extra work to do. A block that you create, and then if it's true, the answer is yes, you better multiply by -1, right? Because in that case, right, it was negative, that's a true, it was a yes answer, so it is a negative number. Multiply it by -1, and then you can print it out. I'll say display the answer. Because then it'll be a positive number. You've computed the correct absolute value for a negative number at that point. If the answer is no, if it's not less than 0, then it's a positive number or equal to 0. If that's false, then you don't have to do anything at all. Just display it. It's already the absolute value of itself. Does this algorithm make sense to us? Because this is a little recipe to get an answer. Do you think you could translate this to code if I showed you what the block is that does one thing or another thing? Any questions about that? Isn't that fun? So, yeah, I'll give you some time to play around with this. That's pretty much all. So, we're good with this idea, yes? All right, here's the answer. Here's how you do one thing or another. Are you ready? It's called an if-then-else block. It lives here in control. It's down here below repeat. If-then-else. This one. Okay? I can't remember if I saved this one, so let me save it right now, just in case. If-then-else. This block can take blocks in the first part and in the second part. It's got two little holes, right? Holes for true stuff, holes for false stuff. Okay? So let me break this down for you. What does this if-then-else block do? It has a slot for a weird-looking shape. This is a shape we have not seen yet. This is not code, right? Because code looks like a Lego. Code like this. It's not a variable or a computed answer because those are round, right? Doesn't fit. It's these little pointy places, these pointy things. And those are computations that create a true or false answer. Those are Boolean valued things. Okay? So this part is called the condition. Redraw that so you can see the word then still. This is called the condition of the if-then-else. Okay? The condition goes here. That's your question that you're asking Scratch to figure out the answer to. Yes or no? True or false? Condition goes here. It must become, eventually, it must compute true or false. Must become true or false. And based on that, it'll either do code 1, you can put as many blocks in here as you want, it'll expand itself, or code 2. Yeah? And so this part is the then part. This is executed if the condition was true. I'll say cond for condition is true. And therefore, I'm going to call this the true branch. And then thing 2 gets executed. All the blocks inside of there, it'll expand itself if you have multiple. That'll get executed if cond is false. That's always one or the other. You can't have an answer that's both yes and no, right? Executed if cond is false. And so I'll call this the false branch. Okay? Does that make enough sense? So, in essence, back to this diagram, this kind of diagram, this code is going to run like this. It's going to check the condition, get true or false out of it. If it was true, it does code 1. If it was false, it does code 2. Whatever you put in there. That's how it's going to run. And then if you want stuff to happen, like it's going to complete its stuff, it's either going to do thing 1 or thing 2. And then when it's done, you can put normal straight line code down here. It's just a giant block at that point, from that point of view. Any questions about that? If then else. Let's see, what do I want? Yeah, that's about it. So let me show you an example of this, and then I have something for you to try and help each other with. So a lot of these, like you can see, like these are things that have yes or no answers. Do I have something in my answer variable right now? That would be very helpful. I have 55 in my answer variable right now, so let me use that really quick. Here are some conditions that I can drag out. Is answer, which is currently 55, is answer greater than 50? Click it. It computes true. The answer is yes, of course. 55 is greater than 50. Is it greater than 100, though? No, that's false. You see that? That's pretty nice. Is answer equal to 50? No, because it's 55 right now. But is it equal to 55? Well, yeah, that's true. See how that computes a yes or no answer? That's what those pointy blocks do. Those are your conditions, and those can drive, I'll duplicate it, those can drive your if then else. If answer is equal to 55, then, I don't know, let's say something. Say true branch. False. And it's only going to be one or the other. False for 2 seconds. So answer is equal to 55. That's true. So it runs whatever is in the true branch. It says in full, it says true for 2 seconds, right? And then if I give it something that's false, like asking if 55 is greater than 100, then it's going to say, okay, the condition evaluates to false, so I will run my false branch. And so it says false. It runs this code down here. Any questions about that? Does that make sense? Checks the condition first, then it does one thing or another. That is your if then else block. All right. So now let me give you plenty of time to help each other do exactly what I asked you, what I promised that I'd ask you about. I would like you now to create a program that generates or computes and gives back, says it back, the absolute value. Okay? Create the absolute value of a number, ask the user for it, spit it back out in absolute value form without using the abs block. Use if then else. Okay? So that is the process. So you need to get the number to take the absolute value of, so you're going to have to ask the user for something. And then you can do what I did. You can immediately say stuff. You can display the number times -1, something like that. Or maybe you can modify, and I encourage you to try this, maybe you can modify the variable x. You are not allowed to change the answer variable, sadly. This block doesn't work for it. This change answer by 1 or something. Set answer to itself times -1. That doesn't work. So you have to put whatever you need to work with if you want to change a value. Like if answer is -42, you got to put that into a variable that you create in the variables section. So you'll put -42 there from answer, and then you can change x now. You can change x by, or you can set x to itself times -1, times up here, something like that. Okay, you can replace the values of the variables that you make, not the answer variable. Okay, so here is the flow chart for absolute value. I'll put this on the slide, and then I want to give you guys several minutes to go off, try and make this work. Maybe try it both ways if you have time. Do it without making an extra variable, just print out the answer, and then also try it with making an x variable, negating it in place, and then printing out x at the very end. Okay? So that's the strategy. I think that is everything that I wanted to give you hints about. Are there any questions about the question? Yeah, so please get into peer instruction groups, work with the people next to you, say hi, help them out, and I'll give you several minutes to try this. Let's start with about 5 or so. But go off, give this a try, and I'll be here to answer your questions. So absolute value block is not allowed. You're making your own. Alright, do we have pretty absolute value programs? No. Power cord. Alright, that is my timer. Did we were able to make something happen? Are there any questions that about things that we encountered as we were trying to make it happen? We'll have perfect programs then. Alright, let me do it with you. Let's see here. Pretty sure I saved that, hopefully. What do we got? We're going to ask the user, right? I'm going to try and run this, convert this to code, right? Get the input from the user, ask them for a number. So enter a number. We'll do it when the green flag gets clicked, because why not? Enter a number. Enter a number. And wait. Then we're going to get that number and answer, right? Going to need that. And so, without changing something, that's probably the easier way, you check, right? If the answer is less than 0, that means it's negative, right? So if answer is less than 0, then if that is true, then the absolute value is -1 times the answer, right? Because we need to make it positive. We just determined that it is negative if we're in the true branch. So say answer times -1. For 2 seconds. Otherwise, just say answer because it's a positive. If this is not true, the opposite of being less than 0 is greater than or equal to 0. So it's positive or 0. There's nothing we need to change. So that's absolute value. Enter number 42, still 42. Enter number 0, still 0 because we're hitting the false branch in either case. -42 though, we hit the true branch because the answer is less than 0. We multiply it by -1 and we spit out the answer. Okay, the updated answer. Did we get that way? Questions about this way? Way number 2, let's do it when the space bar gets pressed. Why not? Let's duplicate most of this. Gonna mostly be the same. Instead of working with answer, let's put answer in a variable. Let's call this one x. It's my favorite name for a variable. And so after we get the number, let's put answer in x. Okay? That's one way we can do it. So now x is answer. So x is 42, whatever, -42 if we type that. Now here's what we can do. If answer is less than 0, let's do it like this actually. If answer is less than 0, we need to negate it, right? We need to set answer, or I guess we're working with x now. X is answer. If x is less than 0, then set x to be itself times -1. That's going to update it. See how that's going to make -42 positive 42? It's going to change the box. That's what's going to happen there. Otherwise, if that's not true, we don't have to touch it, right? So you can just leave it empty, I guess. And then the beauty of this is that after we're done with the if-else, we're down here, and we either made it positive or it already was positive and we didn't have to touch it. We can just say X. We only need one say block outside of everything. After we've done our work of negating possibly, we'll just say it for 2 seconds. So now it's going to be the right answer. Does that make sense to us? So enter a number, 42, still 42, and it's saying X, right? Enter number negative 42. It's going to negate it. Change X to be itself times negative 1. So now it's positive 42, and we'll say it now. Okay? Any questions about this? If you don't need the else, you don't have to add it. There's just an if. There's just a single if without an else. It's just do nothing if it's false. Let's do that one. Same thing. Negative 42, positive 42. Positive 42, still positive 42. Okay? So those are your options, this one or this one. Questions about this final updated version of the program? Happy with that? Oh, do we all sign in for attendance, by the way? Can I stop that without anybody being sad? Yell at me right now if you haven't done it. No? Okay, I'll leave it running for another minute or so. So get that in, and then, yeah, I think that's everything that I wanted to say. Any last questions before I release your next programming assignment? It's a silly one, but it's going to have us practice what we got going on here, what we just learned about. So no S anymore. Let me release your programming assignment 1, because your first one was 0, right? Computer science starts with the number 0. So here is the idea. This is going to be due the 25th. So that is next Thursday, just like you have one due tomorrow. You have another programming assignment due a week and a day from now. And here's what's going to happen. You're going to make a cute little teleportation program. And I've made a nice little video example if the words are not clear enough. I'm hiding the code from you, of course, but I'll show you exactly what's supposed to happen in your program. So feel free to watch that if you're interested. So here's what I want to have happen in your program. You're going to teleport the Scratch Cat or whatever sprite you want somewhere on the screen. Okay, so when you click the sprite, your program needs to do the following. So this better be the event that starts it off. When the sprite is clicked, you better move the sprite somewhere. Make the sprite magically appear in a random place on the screen so they can jump or glide or whatever. There's a block for that. And then I want you to compare, right, because we taught that today. I want you to compare the y coordinate of the sprite, wherever it ends up, and have it inspect that. Say, I'm above the first half of the screen. I'm in the top half of the screen, or I'm in the bottom half of the screen. I said middle here, but I think you get the idea. So you can say whatever you want, but here's what's going to happen. You are going to teleport your sprite somewhere when you click it. So maybe you clicked your sprite and it teleported way up here. And then you're going to look at the y equals 0 line, because every sprite has coordinates, right? And you'll see if the sprite was above that line, you'll have the sprite say, I'm in the top half, or I'm above the middle. Just make it be sentient, know where it is, that's all. If you click it and it ends up down here, like y is 0 or less than it, then you'll have the sprite say, I'm below the middle, or I'm in the bottom half of the screen. Something like that. Does that make enough sense? So this is just me forcing you to practice conditionals is all. Okay, so a little example. Try to make it fun for yourself. Like you can play sounds when the sprite teleports. That's a thing. So here is your requirements. You must use these blocks. You must use a block that contains the word random. It's kind of hard to not use that. And then you need at least one if-else. Okay? You can't hard code anything. The sprite better go to random places each time, and you better inspect the y coordinate, which is a variable. If I go back to Scratch, boop, boop, that's somewhere here. The y-coordinate of your sprite exists as a variable. There it is, y position. Boop. So 0 is where the Scratch cat is right now. If he teleports up here, the y position is 111. Teleports down here, the y position should be 117, negative 117, and that will always update depending on where the Scratch cat is, or whatever sprite your program is affecting. Okay? So use that. That is just a variable that's already set for you. Always stays in line with the Scratch cat. And yeah, so those are the requirements for full credit. Any questions about that program? So that's for my non-programmers in the class, so probably most of us. If you have programmed before, then here is your assignment. Again, if you have talked to me about getting your own personal assignment, then just continue along those lines. If you want to keep talking to me about what next thing you should do, please contact me or talk to me after class. But if you'd like to do Racket, if that's enjoyable for you, this is what I want you to do. So do exercise 5 out of the book. And now for submission, this is what I want us to do. No more screenshots. I would like you to record yourself. Please submit a video for either assignment. Please submit a video of your program running with your code visible so I can see that you did it. Right? It doesn't have to be long. Just make it like a minute or something. Just show it all of its possibilities, right? You can record it however you want, or with your phone, with Zoom, with this fancy program called OBS that I'm using. I can definitely help you, but please record a video of your program running. Okay, same for this one. Show me your Racket program, show me it running, and all fancy, okay? If you're having issues, this time I will still accept screenshots. You better show me your code and like the before and after and all that, so a bunch of screenshots is something that you can upload. But after this one, I want you to get practice with it if you can. I'll help you if you're having trouble. Video recordings will be required for the next programming assignment, okay? I would like you to try to make a video recording for this one, okay? That is the programming assignment 1. Questions about that? Hopefully self-explanatory. I even make a very nice, helpful video for you. And so that'll be due a week and a day from now. All right, I think that is officially everything. So I'll click stop on the recording at least.